Hello guys, um, as a medical laboratory scientist, I choose to start up this YouTube channel so that I can be able to help um, medical students or medical professionals, especially the medical laboratory science students. I believe that they are the ones that are going to benefit more from this channel. Um, this channel is um, is going to help a lot of people who are into the medical profession, but those who are going to benefit more is the medical laboratory science students. Basically, I would like to start with an important topic, which I believe that is an interesting and also a difficult topic as well. And a lot of students have been having challenges with this particular topic. Although this is not the only topic I'll be talking on this my channel, so a lot of topics I'll bring them up, and then I'll talk about them. Then you can be able to pick what you can be able to pick, and then use it for your exams and also for you to be able to practice as a medical laboratory science or as a medical laboratory science or a medical professional. Today I'm going to talk about one aspect of microbiology, which is pharmaceutical microbes, which is an essential and very vital aspect of microbiology, because without pharmaceutical microbe, without a very good knowledge of pharmaceutical microbe, you cannot be able to deal with these microbes. Because at the end of the day, you might end up choosing the wrong antibiotic to set sensitivity the wrong uh, for the wrong uh, microbe or the wrong bacteria. So basically, when we talk about pharmaceutical microbe, we're talking about antibiotics in general. So for the history of antibiotics, the history of antibiotics basically started with Alexander Fleming. Although in ancient times, most people were using plants extracts as a source of antibiotic for them to treat infections and to treat wound infections, and most of them don't know that these plants have uh, antimicrobial effects on these organisms, and during those periods they don't have the knowledge or the idea that microbes do exist. So they only have a feeling that if somebody is sick, they should be given that plant extract and the person is going to get well. But they don't have the prior knowledge of these microbes. But in the late 19th century, people begin to have that idea. People begin to understand that these microbes are responsible for this infection that they they might be passing through, or this infection that they have. So basically, people were aware within the 19th century that microbes do exist. So in 1928, Alexander Fleming, who won the Nobel Prize in 1945, while he was working with an old culture plate of Staphylococcus, he discovered that uh, the, the fungi known as um, penicillin rubem has the ability to inhibit the growth of this staphylococcus. Thereby, he was trying to understand what is making um, this organism to inhibit this staphylococcus. He discovered that this organism is secreting a particular substance known as penicillin. And in 1930s, the 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 scientists, the chemist the chemist and Alexander Fleming were able to produce penicillin from this particular fungi known as penicillin rubem or notatum. So after then, they were able to produce this penicillin in bulk to be able to meet the need of people who are suffering with infection. During the World War II, a lot of people were suffering with complications that are are caused by microbes. So the discovery of penicillin was able to help a lot of people and was able to save their life. So within within 1940s and 1950s, which is known as the golden era, it is termed the golden era because that is the period where a lot of scientists were able to develop and identify a lot of a lot of antibiotics that were able to work on other bacteria, because they begin to discover that the penicillin, some organisms are becoming resistant to the penicillin. So they had to find a way to develop new antibiotics that would be able to work on those um, microorganisms, on those bacteria. So what they did is that they ventured into research and were able to discover a lot of um, antibiotics, such as the cephalosporins, macrolides, and the rest. And then this our modern era, a lot of research is being going on to develop a lot of um, antibiotics, because a lot of organisms are still developing resistance with the current antibiotics that we have on ground now. So basically, I'm going to classify uh, uh, antibiotics. What do we understand by the word antibiotics? When they say anti, it simply means something that is against something. So it means that these are substances that have the ability to inhibit or kill or destroy microorganisms. So therefore, these antibiotics were classified based on their mode of action on the bacterial component. So we know that the bacteria has its the bacterial cell has its own components, and the the major components that these antibiotics targets are the cell wall. There are those antibiotics that target the cell wall. There are those that target protein, that's the ribosomes. Then there are those that target the DNA or RNA or the nucleic acid of the microorganism. So based on their mode of action on that particular organisms, they are being classified. So the the reason why they classify them in that sense is because if you look at it, the bacterial cell is somehow different from the human cell. So one of the reasons why antibiotics cannot affect the human cell is because if you look at their major target area, or maybe what the components of those bacteria are made up of is different from the human cell. For example, the ribosomes of the bacteria are made up of uh, 30s, 50s, and 70s, while that of humans are made up of 80, 40, and 60s. So the antibiotics, for example, like the gentamicin, which is an aminoglycoside that targets the 30s, cannot target the human ribosomes, only the bacteria. That is why those antibiotics are not toxic to human. They cannot affect the human cell. So those are the criteria that you're supposed to put in place when an antibiotic is supposed to be developed You are supposed to know whether that antibiotics has the ability to affect the human cell. If it has the ability to affect this human cell, it should never go into the market. So those are the key factors that you are supposed to understand concerning the development of antibiotics. And so based on those key factors, antibiotics were classified. So the first group of antibiotics are the beta-lactam antibiotics, which are which belongs is a family of uh, antibiotics, because these are antibiotics that have the ability to inhibit the cell wall synthesis of bacteria. Then we have another group of antibiotics are the macrolides. Then the third group of antibiotics are the aminoglycoside, which are the gentamicin, streptomycin. Then the third group of uh, the fourth group of antibiotics are the quinolones and the fluoroquinolones. Then the fifth group of antibiotics are the monobactams. Then other groups are polypeptide, glycopolypeptides, then oxalolidinones. So they are classified based on their mode of actions. These are groups of antibiotics. So the first group of antibiotics that I'm going to talk about, because this topic is a very broad topic and we need to talk extensively so that you can have an in-depth knowledge about this uh, this antimicrobial agents. So I'm going to talk about the penicillin. I'm going to talk about the one family of the antibiotics that belongs to the beta-lactam, which is the penicillin family. So the penicillin family the penicillin family are also known as the beta-lactam antibiotic, because they have they have the beta-lactam ring, which help them to bind to the protein uh, help them to bind to the cell wall of the bacteria. So this beta-lactam helps them to bind to the cell wall of the bacteria. They have the beta-lactam ring. So if you are following my channel, if you are following my YouTube channel, just make sure you check on my channel for you to be able to see an update on the other groups of uh, uh, um, antimicrobial agent that I'm going to discuss, because I cannot be able to discuss them all today because they are is a very broad topic. So I'm going to talk about penicillin in general. So like we said, penicillin was discovered by what Alexandria Fleming. So penicillin, if you look at the structure of penicillin, it has the beta-lactam ring, and in combination with an amino group, 6 amino phenylene, which is an amino group that is attached to the beta-lactam ring, and also a thiazolidine ring that make up the that make up the penicillin. So that is basically the structure of the penicillin. So that beta-lactam is the one that is responsible for 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 binding to the cell wall of the bacteria, thereby leading to the lysis of the bacteria. So most penicillins, they act on um, on the cell wall of gram-positive bacteria. Most of them, they are very effective against gram-positive bacteria. The reasons why they are not effective against gram-negative bacteria is because most penicillins cannot penetrate the cell membrane of gram-negative bacteria. So therefore they are not effective against the gram-negative organisms. So penicillin can be classified into uh, they can be classified into 4 families. We have the natural penicillin, which is penicillin V, penicillin G, and penicillin K. Most people will tell you that they know about the penicillin V and penicillin K and penicillin G, but recently it was discovered that penicillin K also exists. So those are the natural penicillin. Then we have another group of penicillin is extended spectrum penicillin. These penicillins are very, very effective against Pseudomonas infection, and example of that penicillin is carbanicillin, papenicillin. So those are examples of extended spectrum penicillin. Then we have aminopenicillins. Aminopenicillins are called aminopenicillins because they have an additional group, an additional functional group of an amino acid. This additional functional group of an amino acid helps them to be what? To be effective both against gram-negative and gram-positive organisms. So they can be able to act on gram-positive and gram-negative organisms. So because the natural penicillin cannot act on the gram-negative organism. Yeah, they cannot act on the gram-negative organism. So the penicillin V is also known as phenoxymethyl penicillin, and mostly it's a type of penicillin that can be used orally because it cannot be destroyed by the acid in the stomach, while the penicillin G cannot be given orally. It must be given intramuscularly or intravenously because it can be destroyed by what? By the acid in the stomach. And most of the time, for you to be able to administer the penicillin G, it must be conjugated with benzathine or maybe procaine, because there is what we call depot injection. Because what do we mean by depot? Because the reason why they call it depot is because penicillin can be absorbed rapidly into the bloodstream and thereby yielding a minute effect, will not have a serious effect on the microbes for a longer period of time. It will just act for a shorter period of time. But when you conjugate it with procaine, it gives a slower release of the drug into the bloodstream so that it can be able to have a maximum concentration that will help it to destroy the microorganisms. Through the years, so, I go wandering. Basically, penicillin V can be taken orally while penicillin G cannot be taken orally. So those are the difference between the two penicillin. And we said penicillin G is known as benzyl penicillin, while penicillin V is known as phenoxymethyl penicillin. Both of them can be given intravenously, intramuscularly, but penicillin G cannot be taken orally because it can be destroyed by the stomach acid, while penicillin V can be taken orally. So those are the difference between penicillin V and penicillin G. So most of them, they act on the cell wall of the bacteria. Then the methicillin resistant staphylococcus there is another group of there's another group of penicillin that is known as um, is it is known as beta-lactam uh, resistant beta-lactamase resistant penicillin. So why it is called beta-lactamase resistant penicillin is because that enzyme that those bacteria produce help them to neutralize the beta-lactam ring of the penicillin so that it will not be effective against them. That is one of the resistant mechanisms that these organisms have developed so that they can be able to neutralize penicillin for them to be able to survive. So there are penicillins that have been produced to be effective, and so that it can be effective against those staphylococcus infections that have developed it's staphylococcus organisms that have developed beta-lactamase. Example is the methicillin. So, and nowadays we have also discovered that there are specific groups of staphylococcus that have actually developed resistance to this methicillin. That is why they call them methicillin resistant staphylococcus infection. So that is because they have developed a mechanism that will help them to be resistant against methicillin, apart from the beta-lactamase enzyme that they have for them to neutralize the beta-lactam ring. So basically those are the families of the different penicillins that we have and the different groups of the penicillins that we have. So I think I'll stop here and I'll continue with this video in another for another day, and I will take on another group of the antibiotics. So I hope you have been able to learn something from this, although there are lots of things to discuss about this penicillin. You know, the bacterial cell wall has what we call the peptidoglycan layer. So this peptidoglycan layer is made up of two components. These two components are known as NAM and NAC. The full meaning of that NAM is N-acetylmuramic acid, and the NAC is N-acetyl-glucosamine. These are sugars these are chains of sugars. So these chains of sugars are linked together by a tetrapeptide bond of specific amino acids, which are known as the L and D amino acid. So the D stands for D-alanine and the L stands for L-alanine. So these are specific amino acids that links the bonds of this these sugars to form the peptidoglycan layer of the bacteria cell wall. So what this penicillin does is that it inhibits the synthesis of the penicillin. It inhibits the synthesis of the bacteria peptidoglycan layer by breaking down this tetrapeptide bonds that link this peptidoglycan layer of the bacteria. So I guess I think I'll stop here. Then we'll continue with another. If I want to talk about penicillin is a very broad topic, but I believe with what I've said is more than enough for you to understand uh, uh, a little bit about the penicillin family uh, of antibiotics. So I think I'll take in my next video is I'll take on the quinolones. Please just try and be there so that you learn more about the quinolones, so that as you are setting your sensitivity test, you know the right choice of antibiotics for you to use. If you have penicillin, like the group of penicillin, like the ampiclox, like the amoxicillin, like the penicillin V and G, you know that you cannot use them for uh, gram-negative organisms. They will always resist it because they cannot penetrate the cell membrane, not the cell wall, the cell membrane of gram-negative organisms. So as a medical laboratory scientist, always try to learn more about your antibiotics. It's going to help you and guide you in your profession. Thank you.